In this video, we're going to take a look at section 4.1, which is an introduction to polynomials and polynomial functions. Now, our first objective here, we're going to take a look at some keywords, some definitions. So first, a polynomial is an algebraic expression consisting of one or more terms. Now, each term is separated by a plus or a minus. So an example of a polynomial, we have 5x cubed plus 4x squared minus 3x minus 7. So if you take a look at how many terms we have 1, 2, 3, and 4. So this particular polynomial has 4 terms. Now a monomial is a polynomial that consists of one term. So an example of this, 7x squared. A binomial is a polynomial that consists of 2 terms. An example, 3x plus 2. This is a binomial. And now a trinomial, so just like a tricycle has 3 wheels, a trinomial has 3 terms. So it's 2x squared plus 3x minus 1. This is an example of a trinomial. Now let's take a look at another example. So identify the terms, the coefficient of each term, the degree of each term, and the degree of the polynomial. Then identify the leading term, the leading coefficient, and the constant term. Okay. So first, let's go ahead and indicate our terms. Remember, each term is separated by a plus or a minus. Now, if you take a look at the polynomial that's given to us, this is not written in the traditional form where it's in descending order. So descending order is starting from the highest powers and then going down to the lowest. So let's go ahead and rewrite this polynomial first. So we have negative 5x cubed plus 6x squared plus 2x minus 7. So this is important for when we're trying to find the leading term and the leading coefficient. Okay, you want to write it in descending order first. Okay, so let's go ahead and identify our terms. First term, we have negative 5x cubed. Then we have 6x squared. Then we have positive 2x, and we have negative 7. So now we wrote out our terms. Now the coefficient of each term, it's the numerical value of the term. So for our first term, the coefficient is negative 5. The second one is 6. The other one is 2, and then we have negative 7. Now the degree of each term, the degree is the exponent for the variable. So for our first term, the degree is 3. The second one, our degree is 2. The third term, our degree is 1, because this is really like x to the first power. And now for your constant term, the degree is 0. Now the degree of the polynomial is the highest degree that we have. So the highest degree for a particular term is 3. This is the degree of our polynomial. Let me go ahead and write that out. So degree of polynomial is 3. Now the leading term. So the leading term, after you write your polynomial in descending order, is this negative 5x cubed. Let's put negative 5x cubed. This is our leading term. The leading coefficient is the numerical value of the leading term, which is negative 5. And then our constant term, the constant term is the term that doesn't have a variable associated with it. So our constant term here is negative 7. And now we filled out this whole chart indicating our key terms here. Our terms are degree of each term, the coefficients of each term, the degree of the polynomial, leading term, leading coefficient, and constant term. Let's take a look at another example. Okay, so same type of question, but now we have 2y minus 4 minus 5x plus 9x squared y cubed z squared plus 5x y squared. Okay, so now when you're writing this out, traditionally you want to write it out with the highest exponents of x first. So let's go ahead and rearrange these terms. So we have 9x squared y cubed z squared. And now we have two x terms with x to the first power. Let's go with the next highest for y. So let's put 5x y squared. We have minus 5x plus 2y and then minus 4. So in this particular polynomial we have 5 terms. So our first one, we have 9x squared y cubed z squared. Then we have 5x y squared, then negative 5x, 2y, and negative 4. So let's take a look at the coefficient for each term. So for the first term, the numerical value here is 9. Then we have 5, negative 5, 2, and negative 4. The degree of each term, so now it gets a little bit trickier because we have more than one variable. So to find the degree of the term, if you have more than one variable, you have to add the exponents with each other. So the degree of our first term, we have 2 plus 3 plus 2, which gives us 7. So the degree of that first term is 7. Now the second term, add the exponents, so it's 1 plus 2, which gives us 3. The degree for negative 5x is 1. Degree for 2y is also 1. And then the degree for negative 4 is 0. So the degree of the polynomial is the highest degree that we have for a specific term. So our highest degree here is 7. So the degree of the polynomial is 7. Now our leading term, so after we wrote in descending order, it's that first term that we have, which is 9x squared y cubed z squared. Leading coefficient is 9. And then our constant term is negative 4. And now we're finished. Let's take a look at our next objective. So for objective B, we're going to evaluate polynomial functions. So let's go ahead and take a look at an example. So it says evaluate p of x equal to 3x squared minus 2x plus 5 for the following value. So this type of problem we've seen before. So we're given a value for x. So what we're going to do is plug in that value for x and figure out what our function value is, what our y value is. So p of 4, we're going to so for p of 4, we're going to go ahead and plug in 4 in for our x's. So we have 3 times 4 squared minus 2 times 4 plus 5. Now let's go ahead and simplify it. So remember to do exponents first, perform the exponents first. So we have 3 times, now 4 squared gives us 16. We have minus 2 times 4 plus 5. Now continue, 3 times 16 you get 48. Minus 8 plus 5. So this gives us, so 48 minus 8 is 40, plus the 5 we get 45. So p of 4, this is equal to 45. Okay, so let's try another one. So evaluate p of x equals 3x squared minus 2x plus 5 for the following value. This time we have p of negative 2, and we're plugging it into that same polynomial. So we have 3 times, this time we're replacing all our x's with negative 2. So we have negative 2 squared minus 2 times negative 2. I have plus 5. Okay, simplify some more. So do exponents first. So negative 2 raised to the second power gives us positive 4. And we have minus 2 times negative 2 plus 5. Simplify a little bit more. You got 12. And now negative 2 times negative 2 gives us positive 4 plus 5. This gives us 21. So p of negative 2, this is equal to 21. Let's try out one more. So this time we want to evaluate p of 0, and we're still given that same polynomial function. So we have 3 times 0 squared minus 2 times 0 plus 5. Simplify it. So you get, 0 raised to the second power is 0. So we have 3 times 0 minus 2 times 0 plus 5, which gives us 0 minus 0 plus 5, which gives us 5. So p of 0, this is equal to 5. So that takes us to our next objective, which is adding and subtracting polynomials. Now, when you're adding or subtracting polynomials, all you're really doing is combining like terms. Okay. Let's take a look at this first example. Add or subtract is indicated. So I want to add this first polynomial with this second polynomial. Now remember, like terms, these are terms that have exactly the same variable part. Now, first thing I could do here is I could get rid of my parentheses. Notice in front of my parentheses, it's really just like a positive 1. So I could go ahead and get rid of those to start off with. So I have 3x cubed plus 4x squared minus 7x minus 2. And I have minus 7x cubed minus 2x squared plus 3x plus 4. And now I can start combining like terms. Okay, so these two terms have x cubed. I can combine those with each other. So 3x cubed and negative 7x cubed, this gives me negative 4x cubed. So you add the numerical values, combine the numerical values, and keep the variable part the same. Now I have this 4x squared and negative 2x squared. Combining those, I get positive 2x squared. I have negative 7x and positive 3x, which gives me negative 4x. And I have negative 2 and positive 4. Gives me positive 2. And now I just added those two polynomials with each other. Let's take a look at this next problem. For this next problem, a little bit trickier because we're subtracting. So I have this first polynomial and then minus the second polynomial. Now, when you have a subtraction problem, what you have to do is you have to first distribute that minus sign out to both of those terms. So we have 9y cubed minus 2y minus 4 minus 5y cubed plus 8. And now this becomes exactly like the problem we just saw. Let's go ahead and combine like terms. So 9y cubed and negative 5y cubed, this gives me 4y cubed. Now I have this negative 2y, but there isn't any like terms with that, so I just leave it as minus 2y. I have this negative 4 and positive 8. Combining those, I get positive 4. And now we subtracted those polynomials. Let's take a look at another one. So this one a little bit more complicated because we have a bunch of p's and q's here. Just remember, in order for two terms to be like terms, they have to have exactly the same variable part. So same exponents and everything. So let's go ahead and first distribute out that minus sign. So we get 4p to the 4th q minus 5p cubed q squared plus p squared q cubed plus 2q to the 4th. Now distributing out the minus sign, we get plus. We get 5p to the 4th q minus 5p cubed q to the 2nd plus 3p squared q cubed, and then plus 7q to the 4th. Now let's go ahead and take a look at like terms. So 4p to the 4th and then q. Do we have another term with the same variable part? Do right over here. So we could combine those together. We get 9p to the 4th q. Let's take a look at our next one. So this time we have a p cubed q to the 2nd. Okay, we have another one right over here. So now combining those with each other. So negative 5 and negative 5 gives us negative 10. And we keep the variable part the same. Let's take a look at our next term. So p squared q cubed. We have another one of those right there. So remember, there's like a 1 in front of this one right here. So 1 and 3 gives us 4. We have p squared q cubed. And then we have this 2q to the 4th and 7q to the 4th. Combining those together, we get a 9q to the 4th. And we're all finished. Now, one last problem, a little bit harder because we're dealing with fractions. So we have fractions and decimals actually. So first, let's go ahead and distribute out this minus sign to each one of these terms. So we have 3/2 y cubed minus 1/2 y squared plus 0.3. And we have minus 1/2 y cubed minus 1/2 y squared plus 4/3 y, and then minus 0.2. And now let's go ahead and take a look at our like terms. So over here and over here, so these two terms, they have the same variable part, they have y cubed. I could combine those together. And now just be careful here, since we're dealing with fractions. In order to combine fractions with each other, you need the same denominator. But luckily in this case, these two fractions have the same denominator. So we could go ahead and subtract. So 3/2 minus 1/2, I get 2/2. Keep the variable part the same. I have a y squared and a y squared over here. So luckily, once again, they have the same denominator. Now, negative 1/2 minus 1/2. So negative 1/2 and negative 1/2 gives me negative 2/2. I have y squared. Let's go with my next term, which is just this y. But there isn't any other terms that just have y to the first power. So there isn't any like terms for that one. So let's keep that the same. And now we have this decimal part, 0.3 and negative 0.2. Okay, these don't have any variables, so these are like terms. 0.3 minus 0.2 gives me 0.1. And now all that's left to do here is to simplify these fractions. So the 2/2, that just gives me 1. So I'm left with 1y cubed, which is just y cubed. And minus 2/2 is also 1. 1 times y squared just gives me y squared. 4/3, can't simplify that, just leave it alone. And I have plus 0.1. So that was it for section 4.1. If you have any questions, don't hesitate, just email me.